Chapter 5, Section 3, Factoring Trinomials. Before we actually get into the factoring bit, just want to do a quick recap on something that we would have seen before. Suppose we have two binomials being multiplied together. Something like this. Okay. If I asked you to multiply this out, you can use the quick trick FOIL, which is just a special case of the distributive law. So you'd multiply the first two terms, that's x squared. The outside term, so that's plus 6x. Inside, and then the last, 1 times 6 is 6. And then of course we would combine like terms. So that would give us x squared plus 7x plus 6. So this should be familiar. Remember, factoring is the opposite of this type of multiplication. So if we were to start here, how can we actually go backwards to recover this x plus 1, x plus 6? Well, look at these two numbers that we started with. 1, mainly positive 1, and positive 6. How are they connected to these numbers here? Well, if in our minds we add 1 and 6 together, that gives us 7. But if we multiply 1 and 6, that gives us positive 6. So these two numbers here play a role in this coefficient and this constant. Let's see if this works. Now if we want to factor x squared plus 5x plus 6, we need to look for two integers, meaning whole numbers, that multiply to blank and add to blank. What are the blanks? Well, we want to find two numbers that, when added, give us 5, but when multiplied, give us 6. So multiply to 6 and add to 5. Okay, so again, this is what we're factoring. So multiplication, that implies a product. Okay, in the early stages, you're free to make a table, but eventually you'll just be able to come up with them in your head. So two numbers that have a product of 6. Well, what about 1 and 6? Because 1 times 6 is 6. But if we add them, that gives us 7. Okay, but we want a sum of 5, so that doesn't work. How about 2 and 3? Because 2 times 3 is 6. But when we add them together, it gives us 5, which is exactly what we're looking for. So we have found the two numbers that we need. Therefore, we can factor this immediately in one step. This will give x plus 2, x plus 3. Okay? Now I'm going to check this, but I will do that in the next slide. Let's factor another one. X squared plus 17x plus 60. So we want to find two numbers that multiply to 60, but add to 17. So think of pairs of numbers that would multiply to 60. So for example, 4 and 15. Okay, because 4 times 15 is 60. But if you add those together, we get 19. Right? So we don't want that. How about 6 and 10? Okay, those two multiply to 60, but you add them, you get 16. That doesn't work. How about 12 and 5? Okay, 12 times 5 is 60, but 12 plus 5 is 17. Bingo. Those are the two numbers that we're looking for. So we can factor this trinomial here immediately as x plus 12, x plus 5. Now it doesn't matter the order you write them as long as the signs are correct. Right? But let's check them now. See if they're right. Right? So looking above in your notes, we had x plus 2, x plus 3. So if I FOIL them out again, I would get x squared plus 3x plus 2x plus 6. And then combining like terms gives x squared plus 5x plus 6, which is exactly what we had when we started with. Right? So by checking, we know that we factored it correctly. Right, the next one we had up above, we factored it as x plus 12, x plus 5. So let's FOIL it out again. So that gives x squared plus 5x plus 12x plus 60. And then we add those two like terms in the middle, x squared plus 17x plus 60. Okay, that's what we had when we started, so we know it's correct. Let's try a couple more. X squared minus 13x plus 40. So we want to try and find two numbers that multiply to 40, but add not to 13, but to negative 13. Okay. Well, if two numbers multiply to give us a positive answer, okay, either the numbers are both positive or they are both negative. But if we want them to add to give us negative 13, that should tell us right away that the two numbers we're looking for must be negative. This is what I mean. Supposing you check 8 and 5. 8 times 5 is 40. But if you add those together, you get positive 13, which isn't what we want. We want a negative 13. Okay. These multiply again to positive 40, but when I add them together, I get negative 13. So these are the numbers that I want. So we can factor this right away. X minus 8, x minus 5. Okay. Let's just quickly do a check. Foil it out. First, outside, inside, last. Next, we've got x squared plus 2x minus 35. So we want two numbers that have a product, meaning they multiply to negative 35, but when added give us positive 2. Okay, well, if two numbers multiply to give us a negative, that should tell us right away that one number is positive, one number is negative. All right? So let's think of factors of 35. How about negative 7 and positive 5? Because those multiply to negative 35. But when you add them together, you get negative 2. Well, that's not what we want. Well, what if we switch the signs and we choose 7 and negative 5? That still multiplies to negative 35. But when we add them, we get positive 2. So those are the two numbers we need. So we can factor this trinomial quickly as x plus 7, x minus 5. So we're done. Let's just check it for fun. So first, outside, inside, last. Okay. It matches where we started, so it must be correct. All right. Now at the bottom, I just have a list of 3 different scenarios that we may run into when we're trying to determine the two numbers that work. If you look at the very top of your video, you'll see this written: ax squared plus bx plus c. So this is the kind of general form that these trinomials have. But specifically in this video, a is 1. So I really don't even need this anymore, because 1 times x squared is just x squared. All right, so b and c. If we're given a trinomial and b and c are positive, so you would have seen that in the first 2 examples, so have a look at those. Both of those numbers are positive. Then the numbers we're trying to find that go in the brackets, notice how they were both positive as well. Okay. Case 2, what if b is negative? So this number here is negative, but c is positive. So an example would be right here. Here is a positive c, here is a negative b. Okay. Well, both the numbers that we're looking for are negative. Okay. See how both of these were negative? And then case 3, if c is negative, right here, negative 35, then numbers have opposite signs. And we saw that here. Okay, one had to be positive, one had to be negative. So this is just to summarize the different possibilities.